Karanjetlilive.
Hi guys, welcome to my channel, and today in this video we are going to discuss garbage collection and ABA problem in concurrency. So guys, for the full lecture all of you stay tuned. So guys, first thing first, what is garbage collection? So all of you, those who study data structures, okay, they must have come across this term. We call it as garbage collection. What it is? Guys, garbage collection is the process of collecting all the free nodes or collecting all the deleted data and putting them in an available pool. What is available pool? Available pool is another structure in which we append all the deleted nodes so that they can be reused. For example, this is our linked list. So it has three elements. A is pointing to B is pointing to C. Okay, so suppose the address of A is 100, address of node B is 110, address of node C is 120, and then we have a start which is pointing to the first node, that is 100, and C is not pointing anywhere, so that is null. Suppose this is my linked list. Okay, now in this linked list, suppose I delete node A. How do we delete node A? We delete the node A by changing the address of start. So earlier it was pointing to 100, now it will point to 110. So what will happen? Automatically this is start. Instead of pointing to A, it will start pointing to B, and my linked list will start from the B. So you go to start, what is the first node? 110, then 120, and so on. A gets deleted from here. Now this is a deleted node. Okay, this is a deleted node. What is a garbage collection? Garbage collection is the process in which all such deleted nodes are collected together, okay, and they are put in a available list for recycling. Now what is the available list? It is the list of all the deleted nodes, so that whenever we need a new node, we can pick a node from the available list. So here suppose we have a available list, AVAIL list. Okay, so avail list. Now A got deleted, avail list will point to A. So what we have here is the deleted node A. Now suppose in this list node B also gets deleted. How do we delete it? We change the starting address from 110 to 120. So what will happen? The start will point from 110 to 120. Okay, then what do? Again we bring this node B to available list. So what A will point to? Now we will modify our available list. A will point to 110. So what comes here is, after A comes B, and B is pointing to null, and available header was pointing to 110. So what happened? If from this list I deleted two nodes, that was node A and that was node B. So all two nodes, I moved them to available list. So from here we can recycle them. For example, after some time, again we need to insert a node in our this list. From where we will pick the node? We will pick the node from the available list, and we will put the information in it. For example, so I want another node. So what I do is simply I pick this node. What was the address of this node? 100. Initially the address of this node was 100. It will point to 100, and I will modify the header of available list from 100 to, what was the address of B? Address of B was 110. I will point to 110, and here comes, and the next of this node I will point to null. Okay, so then whatever information I want to store, A, B, C, D, E, F, for example, F, I will store in this list. Basically, what is garbage? I hope I make it clear to you. So basically, what is garbage collection? Garbage collection is the process of collecting all the deleted nodes and putting them in the available list. And some people also call it as free pool. Some people also call it as free pool, so that they can be recycled. So that they can be recycled. We call it as garbage collection. Now guys, what happens? The present day programming language, for example Java, the Java virtual machine, it does this garbage collection automatically. It does not bother the user to do the garbage collection. But the old programming languages like C, C++, in that we have to do, the user has to do the garbage collection. Okay, now this was garbage collection. Now coming to concurrency. Now guys, what happens? Java has a very good support for concurrency. Whereas the older programming languages, so they did not had inbuilt functions which could support concurrency. Okay, so in Java, when the concurrent threads are running, on a linked list or on any linked structure, okay, they keep on adding and removing the nodes. And in Java, as I told you, the garbage collection is done by the Java virtual machine. But still, the designers say, so when we are doing concurrent programming in Java, okay, it is better the threads which are adding and deleting the nodes, they should do their own garbage collection. Means all the threads who are deleting or adding the nodes, they should keep a local list of the free nodes. They should keep their own local pool. Okay, now what do you understand by own local pool? Suppose this is my list and I have one thread, TA. Thread number A or thread A. So if thread A is deleting a node, so instead of relying on the Java virtual machine garbage collection, it can maintain its own free pool. So in which it will keep putting all the deleted nodes. Okay. So that later, if the thread needs any node, it can take the node from the free pool without bothering the Java virtual machine. And in case there is no node available in the free pool, then it can create another node by using a new operator. Okay, so this is how concurrency, garbage collection is handled in concurrent thread. It is handled the same way in which it was handled in older programming languages like C, C++. So what happens here? Each thread maintains its own free pool of all the deleted nodes. And whenever a thread needs a new node or a node, so it will first try to get the node from its free pool. If a free pool has a node, it will be assigned to that thread. If free pool does not have a node, then it can create a new node using a new operator. Okay, otherwise it will have its own free pool. Now guys, I hope I made it clear. Okay, so what 2 points we discussed? We discussed garbage collection. What is garbage collection? It is that process of collecting all the free nodes and putting them together in a free pool. Okay, older programming languages, they used to do garbage collection because their compilers did not had any support for garbage collection. But with the new programming language like Java, okay, the garbage collection is done by the Java virtual machine. But still, in Java also, whenever we are doing concurrent programming, it is preferred that the threads, they can do their own garbage collection like we used to do in the older programming language. How does a thread does? A thread maintains a list of the free pool locally. Okay, whenever it deletes a node, it moves that node to the free pool. And whenever it needs a node, it takes a node from the free pool and it uses it. Okay, so guys, I hope I made myself clear until here. Okay, now coming to the final point. Now that is called as ABA problem. That is called as ABA problem. Now guys, what is ABA problem? ABA problem is the problem which arises when the threads they do their own local garbage collection. When the threads they do their own local garbage collection, it can lead to a problem called as ABA problem. Okay, now what is the ABA problem? That we will discuss in the next part of this lecture. So guys, in this part of lecture we are going to discuss ABA problem. Okay, now guys, suppose this is our linked list. It has 1 2 3 4 nodes. Okay, so first node has A, second node has B, then C, then D, and these are the addresses of these nodes. So our linked list starts from node A, and my starting pointer is pointing to node A. Now suppose number 1, I have a thread called as T1. I have a thread called as T1, and T1 wants to delete node A. T1 wants to delete node A. Now guys, to delete node A, what it has to do? It has to simply change the starting pointer from 100 to 110. Automatically it will start pointing to node B, and A will be moved to the free pool. But before T1, okay, now to remove node A, so what T1 needs? T1 needs to acquire the lock on node A. It needs to acquire the lock on node A. All of you know, in concurrency, always we need to acquire the lock on the nodes before we can delete them or before we can modify the list. So T1 wants to delete node A. Okay, and before it acquires the lock on node A, some other thread, for example thread T2, thread T2, it acquires the lock. While this is still waiting to acquire the lock, it acquires the lock and it deletes both node A and B. Okay, so it deletes both node A and B. It set the start pointer to node C. So what is node C? 120. And both A and B, both node A and B, they are moved to free pool. Here is A and here is B. So what was address of A? 100. What was address of B? 110. And the start pointer is modified and it is pointing to node C. Okay, and it releases the lock. Okay, now the lock is available. Okay, again before T1 could get the lock, number 3, there is another thread T3. Again it acquires the lock on the list. And it inserts back A into the list. It takes A from the free pool. It modifies the start pointer from 120 to 100, and A comes back to the list. And next of A becomes 120. And next of A becomes 120 and start points to the A. Okay. After it does this, thread T3 releases the lock. Now, after T3 has releases the lock, T1 gets the lock. It sees the first node. First node was node A. So that is the node it wanted to delete. So it has the address of node A plus last when it was trying to get the lock on A, it had address of A and it also had address of next node. What was the next node to A? At that time that was node B. But before it could get the lock, A got deleted, B got deleted, and again came back to the list. Okay, and again A came back to the list. So then this thread, when it acquires the lock on the list, it checks first node is A. So to delete A, what it does? It modifies the address of start to the next node of A at the first place when it was trying to get the lock. So what was the next node to A when it was trying to get the lock? That was node B. So what it does? It removes the starting pointer from A. It moves the A to free pool. And it modifies the starting pointer to 110. Now why 110? Because at the first time the starting node was A and the next node was B. So it still thinks that B is still in the list. But in reality the B got deleted and B is in the free pool. So it modifies the starting address and start points to B. And from B it does not point to anywhere. Why? Because B is still in the free pool. Okay, so this makes our list inconsistent. It goes to B, from B it doesn't go anywhere, but which is actually my list. So this problem, guys, is called as ABA problem. This problem is called as ABA problem. So quickly we will go through it again. So what happens initially? So we had node A. Address of A was 100, and we had node B. Address of B was 110. Start was pointing to A. So then we had thread T1. It wants to delete node A. So to delete node A, what it has to do? It has to set the start pointer from A to B. Initially the start pointer is pointing to A. So before it could delete node A, it must acquire the lock on node A. Okay. Now suppose the lock on A at that point is unavailable. But this thread knows that starting node is A and the next node is B. Okay. Now suppose before T1 gets the lock, thread T2 gets the lock, okay, and it deletes both node A and B. So A come to free pool. What is address of A? 100. B also comes to free pool. What is address of B? 110. And the starting point starts pointing to node C. So what is node C? 120. Okay. So what it does? It deletes both A and B. Okay. So after this, some other thread T3 comes. After another thread T3 comes, it adds back node A back to the list. So what thread T3 comes? It removes the node A from the list, free pool, then adds back to the list and add backs to the list. Now what are the nodes our list has? A, C and D. And it modifies the start. It starts pointing to A again. Now in step 4, thread T1 gets lock. When it gets the lock, T1 sees the first node is A, and T1 knows at that time, still since it is trying to delete the node, it knows the second node is B. Now it got the lock. So what it does? It deletes the A, again moves it back to the free pool. Okay. Now according to T1, what is the second node? Second node is B. It does not know that B has been deleted. So then it modifies the start pointer pointing to B. So starting pointing to B. Okay, so then what happens? We go from start to B, and B is still in the free pool, and B is still in the free pool. Okay, which leaves our linked list in a inconsistent state. Okay, and guys, this problem is called as ABA problem. This problem is called as ABA problem. So guys, I hope I made myself clear, and I hope you understood what is ABA problem, okay, and how it starts in concurrency. Okay, how it starts in concurrency. And again guys, if you like our video lectures, please subscribe to my channel, please share our videos as much as you can, and all of you, thanks for watching.